Hi, hello, and welcome to the final homework video of the year. Woohoo, so excited. Thanks for going on this crazy journey with me. What we're reviewing here is our triangle trig. So we're looking at cosine rule, area of a triangle, and sine rule. Okay, cosine rule, remember there's one. This one, where it's c squared by itself, helps us find a missing side. This one, where we have cosine c, helps us find a missing angle. So it's the same formula, just rearranged to help us find different things. The one where c squared is by itself helps us find a missing side. The one where cosine c is by itself helps us find a missing angle. Some of the feedback I got about homework videos is that one, there is not enough detail, so I'm going to try to fix that this time. Two, that the problems don't always exactly align, and three, that you wanted more example problems. So for 2 and 3, 2, it is impossible to show you every single IB, like have me actually do every single IB problem, but I will give you hints on these instead of actually doing them, because my goal is to see, once we've learned this concept, can we apply it somewhere else? So I'll try to be more detailed in this. I will give you hints on the left-hand side problems, but I will not give you the answers. If you have questions, you're welcome to email me or swing by tutoring. Okay, so on this first one, the first thing says find BC. Well, a couple things I notice about this triangle. It is not a right triangle. There is no 90-degree angle, so I know I'm going to have to use cosine rule or sine rule to help me find this missing side. Okay, so it tells me to find BC. I'm going to label it X just so I know which side I'm missing. What I always check for first is sine rule. Remember sine rule, you have to have an angle plus its opposite side. You have to have that pair in order to use sine rule, an angle plus its opposite side. So let me check. Well, I have an angle of 50, but I don't have its opposite side. That's what I'm trying to solve for. I don't know the angle here, but I definitely could figure it out because I know an entire triangle is equal to 180 degrees. To find this angle here, I could do 180 minus 112 minus 50. If I do that, if I pop that in my calculator, 180 minus 112 minus 50, that gives me 18. So I know this angle here is 18 degrees. Okay, well, I have this angle, but I don't know its opposite side. Last chance to check. I have this angle, and I do know its opposite side. So that's my pair of an angle and its opposite side. So I know I can use sine rule. Okay, I didn't give you a ton of space on these, so I'm going to do this on a separate sheet of paper. Okay, I've got this triangle here. I always put sine paired with, in the first fraction, its opposite side. So I'm going to have sine of 112 over 5. This is the fraction that I am given. So the fraction that I am given, whoops, paper's a little sideways there. I have the angle and its opposite side. That is the pair I'm given. What I'm trying to find, well, I know I want to find this side, so I'm going to call it x. I'm going to put it on the bottom of the fraction so the sides line up. They're both in the denominators. X's opposite side is, or excuse me, X's opposite angle is 50. So I know 50 goes in the top. It's sine rule, so we make sure it's sine of 50. Once I am at this point, sorry, should have grabbed some other colored markers. Y'all know how I feel about color coding. At this point, I have a single fraction equal to a single fraction, so I am going to cross multiply. So I'll get 5 sine of 50 is equal to, well, let's do this side in purple, x sine of 112. Okay, my goal is to get x totally by itself so I can figure out the missing side. I'm going to divide by sine of 112 on both sides. Divide by sine of 112 on both sides. My sine of 112's cancel, so I'm left with x is equal to 5 sine of 50 over sine of 112. That's something that I'm going to pop into my calculator, but first I want to check that it is in degree mode. I want to check that it's in degree mode because I'm using degrees here with my trig operations. Mine is in degree mode, so I'm going to do 5 sine, oh, sorry, the sine button is here under trig, 50 over sine of 112. That gives me 4.13103. I'm going to round that to 4.13 is equal to x. Okay, now that is information that I want to add back into my diagram because it's probably going to be helpful for me. So BC is equal to 4.13 centimeters. I know it's centimeters because that is my unit given here. Okay, I'm going to add that to my diagram as well. I now know that this side is 4.13. We're going to see if that helps me. That's a 1. We're going to see if that helps me find anything else. My next question is to find the area of the triangle. So area of the triangle, or the space inside. I've got my area formula here. Its area is equal to 1/2 AB sine C. And then I'm going to do that problem right down here. Again, I didn't give you a ton of space on these. Sorry about that. So area is equal to 1/2 AB sine C. A and B have to be side lengths. Well, the two side lengths that I know are 5 and 4.13. So A, I'm going to say is 5. B, I'm going to say is 4.13. Because sine is in front of this, we know that C has to be an angle. C has to be an angle. C has to be the included angle, or the angle that is created by the two sides. So if I sketch down, I said 5 and 4.13 were the two sides that I was using. The angle created by that is 18. So C is equal to 18 because it is the angle created by the two sides. It's my included angle. So from there, I'm just going to plug everything in. A equals 1/2. A is 5. B is 4.13. And sine of 18. Again, just triple check that your calculator is in degree mode because you are using degrees with your trig operations here. And I'm just going to plug that in. 1/2. I'm going to plug it in as 0.5 times 5 times 4.13 times sine of 18. And that gives me 3.19. So area is equal to 3.19. Which is interesting because it's actually, the area is less than the length of this side. This is a very flat triangle. So area is equal to 3.19 centimeters squared. Squared is always what we use when calculating area. Okay, so for your hints on these two questions, first hint here, your calculator must be in radian mode. Your calculator must be in radian mode. Here it's telling us to find or show that AC is equal to 7 centimeters. So we know that it's equal to 7 centimeters, but how can we prove it? Well, in this case, I have an angle on its opposite side, but it's telling me to prove this side, right? It's not asking me to find missing angles or anything. It's telling me to prove that this is true. So what I'm looking at here, I'm given two sides and an included angle. When I have two sides and an included angle, I'm going to use cosine rule. I'm looking for a missing side, so I know I'm going to use the version of cosine rule where C is by itself. Okay? Biggest thing here is this angle, this C, always has to be the side or the angle opposite of the side you're looking for. It's the angle opposite of the side you're looking for. So I like to relabel my triangle. I'm going to call this angle C now, this angle B. So I know that when I'm labeling my variables, this pi over 3 is angle C. A couple other hints on this bottom one here. This one is very, very similar to the one that we did up here. I've got an angle and its opposite side pair, so I know I can use sine rule. And then it asked me to find the area of the triangle. Be careful that you use the included angle. Okay, so some hints on your ones that you do on your own. Biggest thing here, calculator must be in radian mode. You're using cosine rule. Make sure that you label the angle that is opposite of the side you're looking for as angle C. All right, next we are going to look at, this is a multi-step problem. It's actually worth 7 marks on the external assessment. Goodness, I can't get that right. Because there are so many steps to it. So when we read a problem like this, I'm going to show you how I think through the process of solving it, and then I want you to do the same thing here with some hints. So I'm actually going to get a blank sheet of paper here too, because this one's a doozy. Okay, it says the following diagram shows the chord AB in a circle of radius 8 centimeters. That information is going to be really, really important, where AB is equal to 12 centimeters. Okay, it says find the area of the shaded segment. Find the area of the shaded segment. Well, if I'm looking at this, I'm thinking, okay, the only other piece of information that's not labeled in this is what the radius is. So I know that the radius is from the center of the circle to the edge of the circle. So I know that that's 8. Okay, well, as the radius is drawn now, it's not all that helpful to me. But I would think too, okay, I'm working on a section on triangle trig. Let's see if I can draw a triangle. If I go from the outside edge of the circle to the center, that's a radius of 8. If I go from this outside edge to the center, that's another radius of 8. So I have constructed a triangle here that I now know all 3 sides of, and now I can start to figure this out. I used what I knew about the radius to construct a triangle in order to use what I know about triangles to solve. Okay, so if I'm looking at this, I think about my end goal. My goal is the area of the shaded sector. Okay, so let's think backwards from how we can get there. Well, usually the way that I find the area of a piece is I do the entire thing minus a section. Okay, so what I could do here is this entire sector of the circle in green. So the sector area minus the area of this triangle. Okay, if I did the green sector minus the orange sector, I would be left with just the shaded sector. Well, in order to calculate sector area or area of a triangle, both of my formulas, so my area formula of a triangle requires an angle measure. My sector area of a circle also requires an angle measure. So what I need to do backwards planning from there, I need to find the measure of the central angle. Okay, I need to find the measure of the central angle. Well, how can I do that? Well, I have a triangle, and I know the value of 3 sides, and I'm looking for a missing angle. Ding, 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 we have a winner. We are going to use our cosine rule here. Sorry, I'll do that in red so it's in a different color. We're going to use our cosine rule here. So I know I'm going to use cosine rule. So cosine C is equal to a squared plus b squared minus c squared all over 2ab. I know that this is the, oh, you can't see that. I know this is the version of cosine rule that I am using because I'm looking for a missing angle. This is the version of the formula that helps me find a missing angle. Okay, so this is my plan. I needed to find the shaded sector. I knew I could do that by the sector area minus the area of the triangle. In order to do that, I need to know the measures of the central angle. I'm going to start with cosine rule. Okay, so that's kind of how I backwards plan when problem solving. I think about what's my goal, what do I know, how do I get it to a specific rule that I actually have enough information to use. So that's what we're going to do next. I've got my circle here, okay? I'm going to take out this triangle in orange first. So just the triangle in orange is what I'm going to draw here. Triangle looks like this. Side of 8, and a side of 12. Okay? This is the angle that I am looking for the measure of. So this is my angle C. This is angle C. This is side C. So if I'm looking at cosine rule up here, I know that cosine C is equal to a squared plus b squared minus c squared all over 2ab. Well, these two sides, it doesn't matter. They're also the same value, so it doubly doesn't matter which one's a, which one's b. So I'm just going to plug in what I know. Cosine C is equal to a squared, or 8 squared, plus 8 squared minus 12 squared all over 2 times 8 times 8. Okay, I'm going to pop this whole side of the equation into my calculator and see just like I see it and see what I get. So I've got 8 squared plus 8 squared minus 12 squared all over 2 times 8 times 8. And that gives me negative 1/8. That gives me negative 1/8. So I have cosine C is equal to negative 1/8. Well, C isn't totally by itself yet. If I need to cancel out a cosine, I take the inverse cosine. So cosine to the negative 1, cosine to the negative 1. If you're looking for that on your calculator, look where it says trig cosine negative 1 is equal to negative 1/8. If you do not have a calculator at home, Desmos, you can go to desmos.com/calculator. They have trig functions in that as well. So my angle measure is 97.18. So C is equal to 97.18. Okay, so now I'm going to redraw my diagram adding in what I know. 97.18, that was the missing angle, but that's not quite my answer yet because it's not the area of the shaded sector. So I use cosine rule to find the measure of the central angle. Next thing I'm going to look for is sector area. So with sector area, what I am finding is the area of the triangle plus that little half circle. So sector area is this entire piece here. So this entire section is sector area. Well, let's write down what I know about this sector area so far. I know that the radius is 8, and I know that this central angle is 97.18. That should be enough to help me find sector area. Okay, so I'm going to look, if you flip over to the back, your sector area formula is there. It's A equals 1/2 theta r squared. That's your sector area formula. So A equals 1/2 theta r squared. Now we're going to pause here because we know that our theta, or a central measure, theta must be in radians. Theta must be in radians in order for us to solve, okay, without having to set a proportion. So I'm going to convert it to radians. If I have 97.18 degrees over 1 times 180 over pi. This is my conversion factor from degrees to radians. So if I multiply that together, I'm going to do 97.18 over 1 times pi, your pi button's down here on the bottom, over 180. That gives me 1.69611. I'm going to round that to 1.7 radians. Oh, someone's punched holes in this calculator. That's sad. Okay, 1.7 radians. That's my angle measure that I need to use for my sector area formula. So I do area is equal to 1/2 times theta, that's the radian measure I just found, times r, which is our radius, squared. Okay, so if I do that, I get 1/2, so 0.5 times 1.7 times 8 squared. Oops, that's not squared, squared. That gives me 54.4. So area of the sector is equal to 54.4. Well, so I found the area of this entire thing here, but that's not the area of just this shaded sector. Okay, that's not the area of just this shaded sector, but I have found the sector area. Next, I want to find the area of the triangle so I can subtract it out from the sector area. Okay, area of a triangle is area is equal to 1/2 AB sine C. So looking at this diagram, I'll redraw it down here. My triangle looks like this. My degree measure is 97.18. Both of my sides are 8, 8, and 12. Well, I know that this is the angle that I'm going to use. I know that C is going to be equal to 97.18 because it is the only angle I know right now. That means A and B have to be the two sides that create this angle. So A is equal to 8 and B is equal to 8. Okay, so I'm going to plug everything in. A is equal to 1/2. Area, is equal to 1/2 times A, which is 8. B, which is 8. Sine, which is 97.18. Again, we're using degrees here. Make sure your calculator is in degree mode. 0.5 times 8 times 8 times sine of 97.18 gives me 31.75, so area is equal to 31.75. I am so close to my answer, but I'm not quite there yet. I just found the area of this triangle. What I want to find is the area of this shaded sector. Okay, so if I found the area of the entire sector, which was this, minus the area of my triangle, it will give me the area of just the pink sector. So my very last step is to do 54.4 minus 31.75. 54.4 minus 31.75 gives me 22.65. So the area of the shaded segment is equal to 22.65 centimeters squared. Boom, killed it. Man, that was a beast of a problem, but I wanted to show you an example of one where there's not a ton of information given. We have to figure out what is my end goal and what are the steps that will help me get there, or what are the pieces of information I know that will help me get there. So we end with, I wrote it over here, 22.65 is our final area of the shaded sector. Okay, couple of hints on this one over here. In order to find CE, couple hints that you need to know. This is a missing side. In order to find a missing angle, remember two things. Straight lines are equal to 180 degrees and triangles are equal to 180 degrees. That might help you when solving this one. And then on this, you should end up with an angle and opposite side, which you can use sine rule to help you with that. When you're finding DE, well, DE doesn't exist yet. Draw in DE. Okay, so when you draw in DE, you get a triangle that looks like this. Oh, that's a really poor triangle. Okay, looks something like this. This is 60. This angle is 134. You're looking for this. So DE, we are connecting these points to create a triangle. You should end up with two sides and an included angle. So two sides and an included angle. And I'll let you figure out which rule that is. All right, that is everything for the front and hints for the U-try section. We are going to move on to the back of this where we are looking at some fun circles. Okay, now on this section, two formulas you need to know. First one is arc length. The other is sector area. Okay, when I'm talking about arc length, let me get a blank sheet of paper. If I have a circle that looks like this, say that's the sector, the arc length is the piece of the circumference. It's what part of the circumference is covered by that sector. Sector area is the space inside the pizza slice. So arc length is a portion of the circumference. It's the outside or perimeter of the circle. And then sector area is the space inside just that pizza slice or sector of the circle. Okay, so first one that we are going to look at is this one here. It says find the area of the shaded sector. So we are looking for the area of this right here. So I'm looking for this area. Okay. It tells me that BAC is equal to 2 radians, so I don't have to convert here because my measure is already in radians. So I'm going to use my sector area formula. Its area is equal to 1/2 theta r squared, where theta is your angle measure of 2, r is your radius of 6, so I'll plug in what I know. Area is equal to 1/2 theta, so 2 times 6 squared. And I'm going to plug that into my calculator. 1/2 times 2 times 6 squared gives me 36. 1/2 times 2 times 6 squared, is 36. So the area of this shaded sector is 36. It doesn't give us any units here, so 36 units squared. Okay, next one says find the perimeter of the non-shaded sector. So the perimeter of the non-shaded sector. So that's going to be this perimeter here, or this like outside of the circle, okay, of the non-shaded sector. Okay, so that's this outside perimeter plus here to here, right? Because that is the non-shaded sector. It includes both these radii. Okay, so if I'm looking to find the perimeter of the non-shaded sector, I'm going to do the perimeter of the entire circle. So I'm going to do the entire circle minus the arc length of this sector. That would leave me with just the perimeter in green for the outside part. Okay, just the perimeter in green for the outside part. So let me get a handy sheet of paper here. An entire circle, okay, the circumference of an entire circle, circumference is equal to 2 pi r. Circumference is equal to 2 pi r. That's for the entire circle. Okay, so r is our radius. So my entire circle is going to be 2 pi times my radius of 6. My arc length, okay, arc length is equal to theta r. Okay, so I'm going to subtract these from each other. Theta r, theta is my interior angle, r is my radius, so minus 2 times 6. Okay, my interior angle times my radius. Okay, I'm going to pop that into my calculator and see what I get. 2 pi, times 6 minus 2 times 6. That gives me 25, we'll round that to 25.7. So 25.7 gives me, 25.7 gives me this distance here, right? It is the entire circle minus this orange piece. So I've got this distance here, but this shape says of the non-shaded sector, that includes these sectors here. So plus 6 for a radius here, plus 6 for a radius here. So I should have 27.5, that's the outside part, plus 6 for this radius, plus another 6 for this radius. So I'm going to add that together. I get 27. Oh, sorry, this was 25.7. Whoopsies, whoopsies. I switched these numbers around. This is 25.7. My bad. This is 25.7. So 25.7 plus 6 gives me 37.7. So 37.7 centimeters for the perimeter of the non-shaded section. 37.7 centimeters. Okay? On this problem here, you are looking at the length of the arc. So look at your arc length formula. This is perimeter of sector OABC. That's this entire sector here. This entire sector here. So your arc length plus your radii. So arc length plus radii. Okay, and then area of the sector, you're looking for the space inside here. Look to your area of a sector formula. Okay, this is another one, this one in the middle, that requires multiple problem solving steps and trying to figure out what exactly it is you are trying to solve. First, find the length of arc ACB. ACB, you're looking for this arc length here. That's a pretty straightforward arc length formula. Okay, now finding AB, think back to the last problem we did. If this distance is 8, this distance also has to be 8 because it is another radii or radius. You have two sides and an included angle here. So think about what triangle rule you would use with two sides and an included angle. Then it says find the perimeter of the shaded segment. So perimeter is distance around of the shaded segment. That's going to be this plus your arc length. So that's going to be the base of the triangle plus the arc length. Hopefully those are some helpful hints on that one. And then finally, verifying trig equations, everybody's favorite. You've got two trig identities up here. Tangent is equal to sine over cosine. And then our Pythagorean identity. which says cosine squared theta plus sine squared of theta is equal to 1. I don't have the cards for this. You won't have the cards on the test either, so I'm going to show you how I think through them without the cards. So there's a couple different ways that you can do this one. I'm going to do tangent in orange. I know tangent is sine of theta over cosine theta. I know cotangent is just the inverse or flip of that, or the reciprocal of that. Not inverse, I meant reciprocal. So I'm going to flip my fraction, cosine theta times sine theta. And all of that has to be equal to 1. If I have something that is the same in the top and bottom of the fraction, I look to cancel. I see sine in the top and bottom. I see cosine in the top and bottom. Everything canceled out here, so I got 1 is equal to 1. Boom, good to go. This one is a little more complex because I've got some exponents here, which means this might require some factoring. I'm going to do it on this sheet of paper just to be safe space-wise. I've got sine, you can see that, sine x is equal to sine to the third of x plus cosine squared x sine x. So I know that I can factor this because I have some exponents here. I know that I'm going to try greatest common factor here because my highest exponent is 3. I'm going to try greatest common factor here. So I'm looking just to factor this side of the equation. I'll look to solve that side later, but I'm looking to factor just this side first. I've got 3 sine to the third of x. That means I have 3 sine x's. I have cosine squared of x, so I'll write 2 cosines. And then I have 1 sine of x. I'm going to circle what they have in common. The only thing I see in common here is sine of x. That's then what goes on the outside because it is what I factored out. Then what I am left with, okay, what I'm left with inside the parentheses is sine squared of x, because there's 2 of them, plus cosine squared of x. All of that is still equal to sine of x. Now I'm going to start looking for things that can cancel. Well, based on this rule here, I know cosine squared, oh, you can't see that. Sorry, I'm not very good at making sure you can see everything as I'm talking about it. I'll work on that for next year because this is our last homework video. I see that cosine squared theta plus sine squared of theta is equal to 1. I see cosine squared x plus sine squared x here. So I know that this entire thing is equal to 1. So I have sine x equals sine x times 1. Well, that checks out because sine x times 1 is just sine x, so that gives me sine x is equal to sine of x. Check. Done. There, the left-hand side of the equation looks just like the right-hand side of the equation. Wow, this feels like an extremely long homework video, and I feel like I was talking very fast. So if you have to pause, I apologize. That is your last homework video of the year. If you have any questions, shoot me an email or leave me a comment on Google Classroom. I don't know why I'm still flipping this paper over. That's all I got. As always, for the final time, like and subscribe.